So 4.1 looks at the Earth's atmosphere, nitrogen and things like that, and fertilizers. 4.1, what percentage of the Earth's atmosphere is nitrogen? So we all know that nitrogen is 78%, which is close to 80%. When we're looking at 20%, 21% will be oxygen. Carbon dioxide is 0.03 to 0.04%, and the rest is argon and other trace gases. During the first billion years of the Earth's existence, the amount of nitrogen in the atmosphere increased. One source of this nitrogen was volcanoes. So given out by volcanoes. Nitrogen is used to make ammonia. Here's nitrogen plus hydrogen, something ammonia, and it's asking us to use the correct symbol to show that it's a reversible reaction. And the symbol for a reversible reaction is this. So kind of a half arrow on the top going to the right and a half arrow on the bottom going to the left. A reversible reaction can reach equilibrium. Equilibrium is reached when the forward reaction and reverse reaction happen at the same rate. So equilibrium is reached when the forward reaction and reverse reaction happen at the same rate. Fertilizers are formulations that contain nitrogen. What is a formulation? It's a mixture designed as a useful product. So a formulation is a mixture designed as a useful product. Table 4 shows the percentages of chemical elements in a fertilizer. You've got nitrogen 7%, phosphorus 3.1 and potassium 5.8. You'll notice they've given you the symbols as well for nitrogen, phosphorus and potassium, NPK. So most fertilizers will call NPK fertilizers because they contain these three elements. We have to draw the bar for potassium, and we're looking for 5.8. If we look at our table, our graph, it might not be clear, but each little square represents 0.2. So 5.8 is going to be about, more precisely, it's not about anything, it's going to be there. So just one of those divisions below 6. Shade it in as you want. Already labelled, so you don't have to worry about that. Next, it's telling us that this fertilizer has 0.225 grams of iron in every 3 grams of fertilizer, and it's trying to get us to work out what the percentage is, or show you which calculation it is. So it's always going to be kind of the little number divided by the big number times 100. So here's our smaller number, here's our larger number, so we'll divide that by that times by 100. No, not that one. Could be, but the 100 should be on the top, not on the bottom. This one, they've got the 225 and the 3 the wrong way around, so it can't be that one. This one, both of our numbers are on the top, so it's definitely not that one. Oh, here we go, this looks promising. 0.225, the little number, divided by 3.0, the big number, all times by 100, yeah. So I'm happy it's that one. We have figure 9 shows that the use of fertilizers in 4 different countries, A, B, C and D, comparing them in 2003 and 2015. And we have a student that says much more fertilizer was used in 2015 than in 2003. Well, these are the 4 different countries. This is how much was used in 2003, and here we have 2015, and it's gone up in all cases. So I'm going to say yes, has increased in all countries. So that's my first mark. Well, I'd say the smallest decrease is in country D. So smallest decrease in country D. And our last mark, our last of the 3 marks, is for using some data from the graph. So let's talk about A had largest increase, and that was from, well, each of these squares represents 10, so 20 kilograms per hectare, we don't really need the units, up to 200 and that was an increase of 200 minus 20 is 180 kilograms per hectare. Doesn't matter which of these you use, you can pick any to have a look at, as long as you've pulled some data off there and you've done some manipulation. That's what they're looking for.